This is Actuators activity number 6. This is my team, and my name is Ricardo, and I will solve problem 1, which was a problem that I needed to solve. We consider a DC motor with separated excitation or permanent magnets, which is supplied with a voltage of 200 volts and a duty cycle of alpha. We consider that the machine is under constant torque and it requires a constant current of 50 amperes. If we remember, it is a relationship between current and torque. We consider the resistance of the armature as 0.1 and kaphi as 0.099. We needed to determine the possible branch of the duty cycle under the constant torque conditions that we mentioned. So the first thing we needed to do was to find a formula or a way to relate voltage and the duty cycle, which is this formula. But this voltage is the voltage in the terminals, and this voltage is the voltage on the motor. So what we needed to do was to find the expression that relates the voltage in the terminals and the voltage in the motor, and then we substitute the voltage in the terminals over the amplitude of the voltage, and we just get the alpha that was the duty cycle. For the range of the duty cycle, we know that it is from a value to 1, and if we needed to obtain a value uh, below 0, we needed to have a voltage, a speed that is not the maximum. In this case, we consider that the first speed that we would analyze is speed of 0, and with the speed of 0 we just substitute IA and RA, and we get that the voltage in the terminals required to obtain a speed of 0 was 5 volts. So the now the duty cycle that we obtain is 5 volts over the amplitude, which is 200, and we obtain 0.025. So the range is below 1 and over 0.025. Then we needed to obtain the range of speed. And how do we obtain this? Also with the formula that relates voltage in the motor and Ka5, but with this formula we need the voltage in the terminals, and with that voltage in the terminals we obtain the voltage in the motor to be 195 volts, and with that 195 volts we just substitute in here 195 and over 0.099. that was the constant of Ka5, and then we obtain that we have a speed range between 0, that was the previous example in which the voltage was I don't know, I remember it was 5 volts, and a range with a maximum voltage in the motor that was this value. We know that the voltage in the motor, the maximum amount of voltage is equal to 200. So we obtain this value in revolutions per minute and this value in rats per second. Then we needed to know the exact duty cycle when the speed is 1000 revolutions per meter. So the only thing we needed to do was to substitute and force the equation for this to be 1000. This is uh, it remains constant from the beginning, and we obtain that the voltage in the motor is 99 volts. So then we needed to obtain the voltage in the terminals in order to then obtain the duty cycle, because the duty cycle is voltage in the terminals over A, that is the amplitude. So then we get the voltage in the terminals with the voltage in the motor plus these constants, and we obtain that the voltage in the terminals for a speed of 1000 revolutions per meter was 104 volts. Then we obtained that the duty cycle exact for this speed and this voltage is zero point 0.2, and it is a dimensional, it has no units. And thanks for watching.